Welcome everybody. My name is Paul Klopek. I'm working for Elaad, and I will talk and guide you through the demonstration part today. Today we will discuss a number of topics. We will discuss a number of methods of setting up a PKI for ISO 15118. There are different options. So we can have one PKI setup, but we can also have multiple PKI setups. And as already pointed out by Jason in his previous presentation, once you have more than one, then there has to be a form of PKI interoperability. And we will discuss this first, and then we will also demonstrate one of these methods, which is the cross-certification method. So for those of you that have joined us previously in demonstration, we have a history in demonstrating things related to ISO 15118. So the first one was actually in 2018, setting up a plug-and charge and certificate installation chain with OSPP 2.0. And a year later, we had the PKI roundtable event in Amsterdam. And afterwards, a month later, I think we introduced an energy management system with the ISO 15118 standard and OSPP 2.0. And here we are a little bit less than a year later, and now we have taken up the challenge with another new thing, and that is to have more than one PKI and have a look at interoperability between PKIs. So that's for today. This is a high-level overview of the program. We are trying to bit of switching between demonstration and between theory. So I'll first start off with a presentation about PKI interoperability. Then we will have a demo of the plug and charge chains we have set up. We have a break, and after the break, I will discuss the topic of cross-certification. And then we have a demonstration of the cross-certification with the chains we have explained before the break. And one of the methods that will be treated at the end is the certificate trust list, and that will be presented by Joe Mother from VZGROOTCA. So this is a picture you might have seen previously. So these are different variants of setting up a PKI, which you can use for ISO 15118. So there is we have different ones. So you have the one commercial PKI, you have a neutral regulated PKI, you can have cross recognition, cross certification, and a certificate trust list. Now I will go over them one by one. So first there is the one commercial PKI, by which we mean that it's operated by a commercial party owned by a market player. It has a number of advantages and disadvantages. So the advantage is that it's quite simple. When you have only one, it's very scalable because you only have one. And it fits the ISO 15118 specification, but it also has a number of disadvantages because it creates a monopoly and all parties are forced to use this same PKI. And we expect that this will impede the adoption of ISO 15118. And it would also require some things to be in place beforehand. Of course, we have to have some PKI quality rules. And there has to be market regulation on pricing and on fair, reasonable, and non-discriminatory terms for all parties that want to participate. And of course, you have to make sure that the quality rules are followed. The second option for one PKI setup is when you have a neutral regulated one. Again, it has the same advantages in the sense that it's simple and that it already fits the ISO 15118 specification. Another advantage is in this case that the monopoly is in neutral hands, but it also has a disadvantage in the sense that it takes some time to set up and to get global agreement on one regulated PKI. We expect also that this will take a long time and will impede the adoption of ISO 15118. And of course, for this, you would also need these quality rules. So these are two ways of setting up a PKI to set up only one PKI, but as already introduced, we will also look at multiple PKI methods. And one of those is cross recognition. In the case of ISO 15118, this means that if different PKIs trust each other, this could mean that all OEMs install all V2G Root Cas certificates in all cars, or all companies have to join all PKIs. So that's two different ways of achieving this. And it has also, of course, advantages and disadvantages. It's relatively simple and fits ISO 15118. But the disadvantage is that it's sort of dependent on the OEMs for allowing and installing V2G Root Cas. As well, Jason already pointed out, sometimes you don't know with V2G Root Cas you have to install when the car is in the factory. So that's yeah, that's a disadvantage. And of course, the other way around, if all CSOs and EMSPs should need to join all PKIs, it would increase cost for parties, which will eventually be borne by all the EV users, the customers. So I think that's also a disadvantage of that. For this, we also, of course, would need PKI quality rules. But if you have more than one PKI, you would also need PKI interoperability rules. So when you have to sort of have rules about how to the interoperability should work and what the rules for that are. And of course, you need a strict market regulation on pricing and fair, reasonable, non-discriminatory terms. And you have to have a way to make sure that people follow the quality rules and to follow the interoperability rules. So this is the first option for multiple PKIs and to have interoperability between them. But there are more than this one. The second one, we will go into this one during the demonstrations to show. But just first, the theoretical part, in the sense the advantages and disadvantages. This is one where you can also have multiple PKIs that can coexist. And in this case, we do not have the V2G Root Cas all installed in the car, but this is a way where the V2G Root Cas bilaterally agree on cross-certification. So basically, the trust, so the interoperability is not handled in the car, but it's outside between the V2G Root Cas. Another advantage of this is that you, EMSPs can offer contracts independent of what PKI the car it wants to have a contract for. It can offer the contract to for this, and it doesn't put the burden on the OEMs or the dependency on the OEMs for installing all V2G Root Cas in all cars. If new ones join, they have to update and stuff like that. And if in the alternative way discussed in the previous slide, also the charging stations or other companies do not have to join multiple PKIs in case there would be a new one there. The disadvantage, of course, that if you have a dependency changed from the OEM part to the V2G Root Ca operators for cross-certification, you of course have a dependency there for allowing cross-certification. And another one is that it will also include more certificates. So especially on the charging station side, it will increase your memory a little bit, the memory usage. Now also we have to have some stuff in place for this. Again, we have the quality rules and the interoperability rules, and we also have to have PKI operators to agree on cross-certification. So between two PKIs, you cannot have cross-certification without both sides agreeing. And of course, similar to the previous methods, we also need strict market regulation and fair and non-discriminatory terms. And finally, we have an option called certificate trust list. Now we have a separate presentation at the end of the demo, so Joma will go more into the depth of the certificate trust list. So I will skip this for now. So now we're going to the demonstration part. Now I see you see a world map here, and you see a number of companies participating today. So they are all located at different parts of the world. So we have AutoCrypt. You have already met Jason just now in his presentation. We from South Korea. We have Drive from Israel. We have eClearing.net from Germany. We have Gridwiz also from South Korea, also introduced by Jason just now. We have Shell New Motion here in the Netherlands. We have Trialog and Vedicom, both located in France. So this is a bit, as you can see, we are spread around the world for the demos today. So what we are going to do, I will try to explain using my little circle diagrams. And in order to have a sort of a convention, I use colors. So you see the colors here. If I am talking about a component or a system that's from the ElaadNL PKI, then it has this blue-greenish color. And if it's from the AutoCrypt PKI, then it has this yellow color. So these are the setups we will be using during the demo. So we have two chains we will show before the break. So you on the top one, you see the ElaadNL chain with slight difference from the Gridwiz one, where we have an OSPP 2.0.1 setup, whereas Gridwiz uses an OSPP 1.6 setup. you can see the different companies here. They will be introduced during the demonstrations. And the idea is that after the break, we will first discuss cross-certification, and then we will also apply it by switching and trying to charge a car from a different PKI on the infrastructure of the other PKI. So this is a bit of the idea for the demonstration. So let's start. So we'll start with the top one. So I will try to guide you through this. So this is the number of companies. We will be using an EV emulator. It's here. It will be operated by one of my colleagues. And we have a charging station, ElaadNL ISO R&D station, shown here on the picture. We have Drives as a CSMS, eClearing as a roaming platform, and Motion as an e-mobility service provider. The PKI we were using looks like this. So we used the PKI as it was used previously in our demos, where we have a V2G Root Cas by ElaadNL, and it's roaming hub based. So you can see the clearing.net as roaming up here as a sub-CA. And we have all parties under one V2G Root CA. So we don't have any separate OEM or MO Root CAs in use. Now, a little bit more in depth, like I already mentioned, we have a roaming platform set up. We have contract certificate pools and OEM certificate pool according to the as sort of described in the VDE aanwendingsregel. So these are the roles, and this is how it looks like. And the companies, so you'll locate them inside the picture. So we have the e-mobility service provider, Motion. The OEM and the car will be an Elaad emulator here in the lab. We have eClearing as the roaming platform, and Drives as a charging station operator that operates the charging station from a three-log vehicle. So the sequence that we will demonstrate our PKI is, of course, we are going to try and do it slowly, because if we can also plug in a car and see that it works, which is of course the end result of using ISO 15118. But for the sake of the demonstration, we will try to do it in a bit of steps. So what normally would happen, there would be an OEM certificate created when the car is created, and it would be sent to the OEM certificate pool. Now today we have already prepared that because our little car here is already created. So the next step we will present is to create a contract. This will be done by the e-mobility service provider in Motion. It will be sent to the contract certificate pool by using this OEM certificate. Chris will explain later. We will show how it arrives at the roaming platform, and then we will plug in the EV and we'll see the contract being installed. So let's shortly go over this routine. So let's start off with the first step, and that is that Chris will create a contract. So handing over the mic to Chris. Maybe you can also put on your webcam. Hello, Chris. There you go.
Thank you, Paul.
Hi.
Hello, everybody. This is Chris from Motion. So in this scenario, one of our customers has purchased an 15118 compatible car and has let us know the PCID that came with the car. So I'm now using the PCID communicated to us to download the so-called OEM certificate for the car. And we will then create a contract certificate that enables plug and charge use cases. And it is tied to the OEM certificate and can only be used with the car from which the OEM certificate came from. So I'm using our tool for it and uploading it to the contract certificate pool. And it should be there by now.
Okay, well, thank you very much. Yeah, well, maybe we can have a sneak preview then to see whether it's indeed arrived. So let's go over to the platform then by Anas. So maybe Anas, you can shortly show whether everything is prepared and received by the platform.
Yeah, sure.
Hi, Anas.
Hi, thank you, Paul. And Here, as a roaming platform in the OEM certificate pool, we see that the OEM certificate is here, which is this one. And we see that the contract, add contract certificate request made by the new motion, the OEM, the provider has also arrived, which is this one. And when the charge point operator will make the request of the get contract certificate, when the emulator or the car is plugged in, we will send this certificate to the charge point operator without appending the cross certificates, because the car belongs to the ElaadNL PKI. That's our role in this chain. Thank you, Paul. Control back to you.
Thank you very much, Anas. Okay, so now we have everything prepared at the central location. So now it's time to plug in the EV. So let's do that. We have to. Okay, there we go. Yeah, I will mute my screen for a second. So, okay, there we have the station. So now my colleague Jesse will try to plug in, so we can. So he has an emulator here that's on the side that will install the certificate that has just been prepared, and it will take some time. Normally this will take only a few seconds, but in this specific case we have all kinds of logging, and we have specifically made sure that it goes slowly enough for for everybody to see. So you can see the light, it's still green at this moment, but it will turn blue in a second, and then that means that the certificate has been installed and it will try to authorize. I hope this is a bit visible on the screen. I can see it in real now. It's all light blue at this moment, and it's going to be turned. Now it's turned into dark blue. And there you see my site. You can see that I'm sitting next to it. Okay. So as explained previously, so the contract is now installed and the car is now charging. So you and the animation you just saw on the slide has now been executed. So this is a bit of the setup we used. We used this previously also in previous demos, and this is the one we will use after the break, when we will use it to apply cross certification for PKI interoperability. So that's it from our side. So now going to the second PKI we will be using for the demonstration, and we will go over to the AutoCrypt Gridwiz side for that, and I will hand over the microphone to Wales from Gridwiz for that. We are seeing your slideshow not completely correct yet. Maybe
okay, so can you hear me, Paul?
Yes, I can hear you, but I cannot see your slides yet.
Yeah, okay, maybe I could just start my screen. Okay.
There you go.
Yeah. Great. Okay. So hello everyone, welcome to Gridwiz E-mobility Laboratory in South Korea. My name is Wales Kim, and I will walk you through the Korean part of the demonstration. So moving on to the presentation where Paul left. If we compare to what you've just seen from the Europe side, we have a compact number of actors with only two participants. Most of the back office roles, such as the certificate authority of the V2G Root and the e-mobility service provider, is supported by AutoCrypt, and it's depicted as blue on the right. Due to the absence of commercially available ISO 15118 PNC vehicle, we are going to use an EV emulator with a PNC-enabled EVCC within. Also, the charging station and the CSMS capable of ISO 15118 plug-and charge will be provided by Gridwiz. So the next slide. So this is an example of a certificate installation process, just to give you an overview of our implementation details. So first, the EV emulator or the vehicle will send the certificate installation request to the charging station using ISO 15118 messages. And then the charging station will forward the request using the data transfer message defined in OCPP 1.6. Here, the content of the data transfer request is in fact the get 1511 EV certificate message defined in OCPP 2.0. So what we are basically doing is backward applying the messages defined in OCPP 2.0 to OCPP 1.6. This concept was proposed in a white paper by Has to Be E-Mobility from Germany, but we made some modifications for better implementation to our end-to-end system. Next, we use AutoCrypt's PNC secondary actor service to receive the certificate chain from the back end. So I will now hand over the mic to Dr. Ju from AutoCrypt, who will tell us how certificate provisioning works from their end. Okay, please take over.
Thank you. I'm Kyoju from AutoCrypt. On the other hand, certificate installation response message is prepared through the separate procedure. AutoCrypt EMSP issues a contract certificate using the MOCA, and it is passed to CPS. CPS then collects all the contract relevant information as a package, and CPS also signs the package and it passes to CCP. And CCP is waiting for request. And on request from OCPP server of Gridwiz, the certificate installation response message is passed, delivered back to OCPP server, Gridwiz.
Okay, thank you, Dr. Ju. So as you mentioned, the contract certificate chain is sent from the AutoCrypt server to our OCPP server. And the propagation of the response message, if it includes the contract certificate, is the exact opposite of what I've shown earlier. So at the end, the contract certificate is installed within the vehicle and will be used for PNC authorization later on. So on the right is the PKI setup for the Korean side of the demonstration. Unlike the European PKI, where all the subordinate CA certificates were issued by ELAAD, we opted for multiple root CA scenario. AutoCrypt is the certificate authority of the V2G root, mobility operator root, and its subordinate CAs, and the certificate provisioning service root and its sub-CAs. While Gridwiz is the certificate authority of the OEM root and the sub-CAs, as well as the CPO subordinate CAs. So what we're going to show you on the demo, first, we'll show you the original implementation of ISO 15118 plug-in charge, where the infrastructure and the vehicle will share the same PKI. We'll first demonstrate the successful TLS handshake, as well as the contract certificate installation and PNC authorization. And next, we are going to change our EV emulator to a different one that uses the European PKI, which metaphorically means changing from a Korean vehicle to a European vehicle. In this scenario, the charging station and the vehicle will fail to establish a TLS communication since they do not share the same PKI. Okay, and during and after the demo, I'll use our analysis tool to show you the current communication status and logs. On the left is the message list panel where you'll be seeing Slack, SDP, and various request and response messages. On the top right is a certificate viewer, which will show you the certificates exchanged between the vehicle and the charging station. And below that is our OCPP server log, which visualizes the messages exchanged between the OCPP client, which is the charging station, the OCPP server, and AutoCrypt server. And after that, we also have a look at the logins from AutoCrypt as well. Now I'm going to change the perspective of our camera and introduce to our setup as well as our main demo. So on the right of your screen is our reference charging station that uses our PLC communication controller Performance Plus. It uses a CCS Combo 1 connector, which is standard in South Korea and supports ISO, DIN, and OCPP 1.6 for the communication side. On the left of your screen, you'll notice two square-shaped devices with a South Korean and a European flag in the front. These devices are our electric vehicle communication simulator. We call it Simplement. And encased within is a PLC controller for the electric vehicle named Applement. The one with the Korean flag has the AutoCrypt V2G Root certificate pre-installed, and the other with the European flag has ElaadNL V2G Root certificate pre-installed. The plastic box on the back is a breakout box, so we'll connect each emulator to the breakout box so that we can plug in the combo connector via an inlet. We will switch between the two emulators, which metaphorically corresponds to changing the vehicle between Europe and Korea. So now we will connect the EV emulator with the Korean PKI and plug in the connector. Okay, now that's done. Now I'm going to turn back to my screen. And here it is. So since this is a Korean PKI-based EV emulator, I'm going to select the V2G root as to AutoCrypt. And now we're going to start the charging from the vehicle side. So you can see the select process is ongoing on the left side. You can see the OCPP log view on the bottom side. Certificate installation is in process. And now we are in the current demand sequence, which means power transfer is in progress. So we will stop the charging from the vehicle side and have a look at the logs. So our main point of interest here is actually the top right side, the certificate view, and more specifically, the TRS handshake. So as mentioned earlier, in the vehicle, we have the AutoCrypt V2G root pre-installed. And given this V2G root certificate, the question is, can the vehicle trust the TLS server's certificate chain, which is sent by the charging station? And if we have a look at the last certificate in the chain, is now the issuer is AutoCrypt. So since the vehicle has the AutoCrypt V2G root pre-installed and it trusts this issuer, it can successfully verify the entire chain and thus a successful TLS handshake. Another point of interest is the certificate installation request and response. But as mentioned earlier, from the charging station's perspective, it only forwards or bypasses the message in between the infrastructure and the vehicle. So let's now check the logs from the other actors, namely the OCPP server and the AutoCrypt server. Now I'm going to pass the mic to our OCPP server developer, Walter Kim. Please take over.
Hello, I'm Walter Kim, in charge of the OCPP server. First, I briefly explain our UI. On the left is our charge point, which is basically on OCPP client. On the center is the OCPP server. On the right is AutoCrypt SA server. If we have a look at the message sequence from the top, first, the charger sent certificate install message to OCPP server using data transfer, which was then forwarded by the OCPP server to our AutoCrypt server. Next, the OCPP server received EXI message from AutoCrypt server, and this imported the received data charger using data transfer. We can see that a similar sequence took place after installation, which is program charge authorization process using ISO 50118 payment details. Thank you.
Okay, next we'll briefly look at the logs from AutoCrypt and see what they have seen in the previous charging session. Please take over.
Now you're watching the log page of AutoCrypt secondary active services. The second line is certificate installation request and response. The response contains the OEM provisioning certificate and root certificate of the vehicle. The EVs checking EV's root certificate, CPS finds that it is under the same V2G root, so it follows the standard process, normal process of preparing CPS leaf certificate, sub 2 certificate, and sub 1 certificate. The 3 certificate, please remember that there are only 3 certificates, 3 CPS certificates, and contractor certificates. So normal cases finish it.
Thank you, Dr. Zhu. We are slightly overdue, but we'll fast forward to the next part and show you the negative demonstration of the ISO 15118. So now I'm going to change our perspective for a moment. So now we've connected to so we've now connected to the left side of our EV emulator, which is based off the European PKI, and we have now connected the charging cable to our breakout box. So I will now change to our main screen. Refresh. Okay, so since this is based off the European PKI, I'm going to select ElaadNL's V2G Root CA. And now we will start the charging from the vehicle side, and let's see how it goes. And this is it. So long story short, since the vehicle or the TLS client only has the V2G root certificate from Elaad, it cannot verify the certificate chain sent by the charging station. If you see the last certificate in the chain, it's issued by AutoCrypt, and this is not recognizable by the vehicle or the TLS client. So in this case, TLS handshake has failed, and thus no charging can be established. Okay, so this ends our part of the demonstration where we don't use the cross-sign certificates. We'll return after the cross-sign certificate introduction, and we'll see you later. Thank you. Bye-bye.
Thank you very much, Wils. Maybe I can get back to screen for 1 second, Martijn. There we go. Okay, so now we have seen 2 working setups. So thanks again very much for everybody for explaining these setups. So as indicated, we have 2 setups, and as already shown by Wils, if you would just connect another car to another PKI, it will not just work. So the next step is to make these 2 PKIs interoperable. Now, the first option that we discussed today was cross recognition, so that when you have the EV installing each other's V2G roots. But as already announced before, after the break, we will use the second method for PKI interoperability, and that is cross certification. But I think after all this talking in this first demonstration, it's a first time for a coffee break, and I hope to see you after the break, and then we will discuss the cross certification and do the demonstration. So thank you.